So for this afternoon, we will have a discussion on what do we mean by equilibrium or equilibrium of forces. Now, we understand that when we deal with objects, if we have bodies, for example, like if we have a crate, so this one, for example, we know that if we position this on a platform or on a surface, if that is placed on a surface, that granting that this is a floor, for example. So if we position that in a floor, and we know that it's impossible that bodies will not act on the object, so or forces will not act on the object. So maybe there will be several forces that will be going into this body. So again, it's highly unlikely that there's only a single force that will act on this object. So in real life, there would be a multiple set of forces. Now, for example, we can call the varied forces there as F sub 1, maybe F sub 2, F sub 3. And again, these are the different forces that goes into the body. Now, with the existence of all these forces, however, it was observed that the body remains at rest, despite the fact that there's 3 or more forces acting on the body. The body did not budge, did not move, did not slide. It did not even attempt to start sliding. So we say that when the body continues to be, that the body is in a state of what we call, it's an equilibrium state. A state of rest, an equilibrium, a state of balance. So we call it the word equilibrium by several names. So maybe it's a state of balance, state of rest. Now, however, we could also consider a body that's not actually at rest but sliding, Pero ang body nga nag-slide naman, in another situation, pwede man nga ang inang body could be in motion. But the motion of the body, despite the fact that it is sliding, ang yan naman yung paghulag sini, So let's say this is moving to the right, So may siya velocity. Now, what was observed with the velocity of the body is that it is moving with constant velocity. Direction is the same, maybe left to right lang gid. It's not changing its direction. Its speed is always constant, so we can probably consider now that this body is moving with constant velocity. Now, when we consider a body to be moving in constant velocity, and pwede man nga ini nga body, despite na nagahulag siya with constant velocity, still, forces are acting as well on the body. So despite that forces are on the body, maybe again, F's 1, 2, and 3. So despite these different forces, our body still moves with the same speed. Wala sa nag-accelerate. So that's also an indication of a body that is in a state of equilibrium. Now, what is similar to both of these conditions? So again, in this next body that is sliding, this is still considered to be in equilibrium. Again, the reason why we consider them to be in equilibrium is that in both instances, the net force happens to be 0. Both net force are equivalent to 0. Now, again, what's the result when the body's net force is 0? It will either remain at rest, or if the body is already in motion, but there's no net force, the body will move with constant velocity, or this is what we call last time as uniform motion. So again, we can achieve a condition of equilibrium in these two instances. No? So maybe now in these two situations, what we achieve actually now is what we term as now the first condition for equilibrium. No? Now the first condition of equilibrium is that it deals with the forces that are acting on the body. No? Now, if it happens that when you add up all these forces, no, which we call as the sum of the forces, no? So again, no, what we achieve here is the first condition for equilibrium. And the first condition for equilibrium is mentioning no, about a certain, no, what we call sum of the forces, no? Or the vector sum of these forces. No? Now, when the sum of these forces, which we commonly no, indicate by a summation symbol. No? So if you have F there, no? And if the sum of all of these forces that are acting like F1, F2, F3, no? And they all add up to, again, no, 0. So again, now we indicate the symbol of sum of the forces, guys, by drawing something like a an E symbol. No, we call it as the summation symbol. So kung makita tani, no, it indicates nga may gina-add kita. No? We are adding F1, F2, F3. Pag walang ila total sina, no, if all of their total is 0, then this body will remain at rest. No? Now, if the body is already sliding, but the sum of all these forces again are 0, then the body will simply slide with constant velocity. There would be no acceleration that results. No? Now, again, in one combined expression, no, that's the sum of forces. But actually, we can divide the sum of our forces here no, as either as horizontal. No? We could split it up into horizontal forces, which we usually call as Fx. No? And if the sum of the forces in Fx is 0, then that's one condition that we satisfy equilibrium. No? However, there's also another set, no, which we call as the vertical forces. No? And commonly when we deal with vertical forces, we term it with Fy. No? And if the sum of these forces along the vertical axis is 0 also, then the body will be in a state of equilibrium. No? Now, let us try to have an example, and I will illustrate to you a particular example. No? So this is the first thing that we will establish. We will try to show this. No? So we will try to show the first condition for equilibrium. Again, in the first condition for equilibrium, we have to show that the forces acting on the horizontal axis or Fx, they add up all to 0, and likewise the forces that goes vertically or move vertically, they also add up to 0. So once that happens, the body will remain steady in its location. So our simplest situation for equilibrium will be the one that is a body that is suspended or simply hanging. So what we have again is a body that is suspended and may ara siya weight, maybe siguro isa na siya ka-box, may cable. The cable is held at a certain angle, and then the cables are connected to the roof, or maybe ceiling, or a fixed structure above. And let's say that horizontally, so if this is the horizontal line, our cable forms a certain angle. So maybe somewhere here, we have theta 1, theta sub 1, or that's angle 1. Let's just draw our theta value. So we have here theta sub 2 also. We have theta 1, we have theta sub 2. So theta sub 1 is on the left side, and theta sub 2 is on the right side. Nga condition nila. So again, now we split the situation here. So case 1 is when our angles there now happens to be the same. So what is its implication? What will be its effect on the tension of the cable when the angles there that are forming horizontally are the same? So well, by that we mean that theta 1 is equals to theta 2. And again, this is our angle measurements. So whatever that angle is, so pwede mo na siya 10 degrees, pwede siya 20, 30, whatever is the angle. Basta, ang atong situation there is that we have two angles that happens to be equal to one another. So what will be the effect on our forces? Now, we can easily identify the forces here by looking at our free body diagram. So free body diagram of our situation there. So if you'll consider the free body diagram, we can actually split our tensions 1 and 2 into components. So we could have tension 1x. And tension 1x could be the horizontal component. So di na makita ang horizontal component naman. So the horizontal component of tension 1 will be due to the angle formed by tension 1, and that will be along the horizontal line. Amo niyang T1x. This is the horizontal component of T1. Now, if it has a horizontal component, then may ara na siya vertical component, which we call as T1y. So, pila ang value natin sa T1y, ang pila ang value sa aton T1x. Now again, these components will depend on our sine and cosine functions. So this one, first value is dependent upon T1, and that will be cosine of theta 1. So that will largely depend on that value. Ang atong T1y will also be equivalent to that will be equals to T1 cosine or sine, sine theta 1, or yes, theta 1. Okay, so this is our so we have eventually on the other end, if we have T1x and T1y on the left side, then we will have T2x, which will go right, and we will have also T2 sub y, that will go up. And these two components again will make the value of our T sub 2. Manakaroon ng atong value sa T sub 2 dira. Okay, so how much is that value? Paano natin nakuha ng atong T2x? Or T sub 2x will be equivalent as well to T2 cosine of course theta 2. Because we have there an angle theta 2. Now again, bear in mind that theta 1 and theta 2 are the same angle measurements. So, amo na sila nga duha. So, T1x goes left, T2x goes right. So, these are the two horizontal forces. And then, our vertical forces that we know are T sub y's. So, ang T sub 2y, so meron kita din T2y. And how much is the value of our T sub 2y again? we have T2, and it is in terms of sine. No? And of course, this is our theta sub 2. No? It's in terms of theta sub 2. No? Okay, now let's split our forces. No? So let's go into the horizontal forces first. No? So along the horizontal line, we have the following forces. So if we will call that as Fx, anong ara sa ating F sub x na? What are the forces along the Fx value? Now, Fx value will have T, no? T2x, bale, no? Kaya kita da T2x going right, no? And then we have a force that goes left, no? We subtract the force that goes left. So that's T1x, no? That the one that goes left. No? Muna sila nga duwa, no? Then therefore, if they are equated with each other, no? And the body there no, is not actually moving, so meaning no, their total must be simply zero. No? And if their total is simply zero, then we realize that we can equate, no, actually, P sub 2x, no? We can actually equate that not to our no, T1x. So may equal sila nga duwa kay sila lang nga duwa sa horizontal line. No? One goes right again, one goes left. So if their total is zero, then they must be the same no? In value. No? Now our T2x is in an equation. No? This is actually P sub 2 cosine no? Theta 2. No? So this is equals to this expression. No? Whereas our T1x is T1, no? That's cosine of theta 1. So these are angle measurements. No? Now, what can we conclude here? If theta 1 and theta 2 are actually equal, no? So if we will substitute the value there. No? So what is the implication if the angles are the same? Then the tensions actually no, will be actually no, the one that will be the same. So sa horizontal forces, no, what we can eventually conclude, no, we can actually conclude that ang tensions natin da, no, when the angles form are equal, the tensions actually will end up to be equal as well. No? Amo ning implication niya. No? That will be the natural flow of its implication. No? So again, theta 1 and theta 2, no, kung kwaon mo ang cosine theta 1 and cosine theta 2 if they are the same, no? If you divide it with each other, no, you'll notice that they will be simply equivalent to 1. No? Therefore, in ending, no, that the tensions will be proven not to be the same. No? Now, if that's the case of vertical or horizontal forces, vertically, no, we can also no, establish no, these equations naman. No? So looking at the vertical forces. No? So what are the forces that are found vertically? No? So we call it Fy. No? What are the forces that are present? First of all is T1x. No? Yeah, kita T1x that goes up. What else goes not T1x no, but T1y gali. No, that's going up. No? So the one on the left side, this one goes upward. No? T2x is also going upward. So we'll have there T2 no, T2 sub y I mean. No? Okay, so T1y and T2y are both going up with the force that is W that goes down. No? So since W is going down, then we can subtract W. Now, the three forces here now that are acting vertically, no? T1y, T2y, and W, when you sum them up, no, ang ato ni nga body nga blue, no, wala man ni siya nagahulag vertically, no? Because what we believe do nga nagapundo na siya because it is suspended, that the sum of the forces there eventually now is equivalent to zero. No? Now, if that's the case again, now we will notice that we can now make an equation that our t sub 1 now being t sub 1 sine theta 1, no? And our t sub 2y is equals to t2, no? That's sine of theta sub 2. That will now be equivalent to our weight W. No? So we can equate it now to W. No? Now, on the left side, no, on the left side equation, we established that t sub 1 and t sub 2 are equal. No? So therefore, now we can actually now simply replace it with a certain variable t. No? If t1 again, no, t1 and t2 is equals to one another, no, then we can just simply call it by a single variable t. No? If our angle also, no, is equal, then we can just call it by a single variable also theta. So we will see here that our angles and our tensions are the same. Now, by doing that, now we can simply rewrite this, no? And why not call this simply instead as t sine of theta, no? And then also, no, call it t, okay, since t1 and t2 are equal, then sine theta 2, no, call it instead by the same variable theta, no? And equate it now to our weight, no? Now you'll observe that the first two expressions on the left side are actually similar expressions, no? And if they are similar expressions, according to algebra, if x and x is added together, then you'll end up with 2x. No? So in this case, you'll end up with 2 t. No? You'll end up with 2 t sine of theta, which is equals to our weight. No? Mula na karoon ng equation natin. No? And what's the implication? How then, or how much then is our tension? No? Since tensions are the same, no, for both sides. So T, no, can simply be equivalent to W, no, divided by 2 sine of the angle theta. No? Now this is only possible when our angles are similar, no, on both sides. So if we suspend something, no, in the air, and that body is not actually moving, no, then we can get the tension on the cable, since the tensions will end up to be the same, to be simply equivalent to this value. No? Okay, so do you have a question about this?